Okay, good evening all. Right, last day we discussed about SDLC, System Development Life Cycle, and actually we have summarized the lesson, and we have almost done everything, right, except two things, that is basically software development models, right, the software development life cycle model. Except that, we have done other work, right. Can you remember the steps of SDLC? Yes. Can you remember the steps of SDLC? What is the first step? Lashen? Anuja? So what is the first?
Identifying the problem.
Yes, identifying the problem. What is next after that? After identifying the problem, yes, Anuja? What's next? You have to talk, come on. You have to talk, right? Just even, I don't mind. Looking at the note in this stage, I don't mind. So you can even look at the note and tell me the answer. That's totally okay, because still I know you have not studied and maybe you have not heard the things, because but anyway, you have the examination last week, no? Next week, right? Next week you have the examination, the term test, same day, same time, and it's Friday, same time you have the examination. You can just face, and that is the first terms covering the first two lessons, right? Okay, so the second one is requirement analysis. After finding the problem, the second one is analyzing the requirement with the is there. So for an example, problem can be, yes, you need a system to keep track of student data. The requirement can be, yes, tracking student attendance, the tracking students, maybe teacher attendance, tracking in time, out time, and as well as tracking exam marks, storing exam marks, generating reports, likewise. So one problem is there, that means disorganized data related to the students, but requirements may vary. And that is anyway related to the problem, but different requirements will be there. So after that, what is the process? So let me summarize and start. After identifying the requirement, what is next? Yes?
Designing the solution.
Yes, finding a solution, designing a solution, basically. Actually, even before designing, you have something called feasibility study. So find out the most feasible solution and most feasible requirement, because everything cannot be satisfied in every way. It's not possible, right? So everything in every way is not possible. Everything every way for everyone is almost not possible, right? So anyway, you have to find a best alternative, best way to satisfy the best people to give the solution. Likewise, you have to find the best alternative among the best technologies to be used, most cost effective way, most efficient way, and most economical way. Likewise, you have to find out the feasibility. After that, then the designing. In the designing phase only, you are using this flowchart, pseudocodes, structure charts, and maybe ER diagram, DFD diagram, but those are not there in your syllabus directly. UML diagrams, those are also not there in the syllabus. But anyway, you have flowchart and pseudocodes. So that is in the system designing phase. So planning itself is not enough. I have seen enough places their plans are implemented. These plans are explained. So sometimes in some roads, in the beginning of the road, so there's a very ancient year, so very old year, and mentioning that this road is subjected to develop under this project. But that development never happened. So that is like planning without implementation. Planning without implementation is meaningless. Because why you plan there? If you don't want to implement, why you plan? So that's the thing. So whatever the plan should be implemented. That is implementation using coding. So in software, implementation is done not using concrete and not using blocks, not using bricks. So it's using codes, right? So using coding, you do the development part. After the developing, yes, what is next? After the developing, what's next? Okay, think that you have coded. After finishing the code, what you can do? What should be the next? Yes? Nothing?
Test it.
Yes, testing. After development, you have a phase called testing. So there we have different test types. We learn about 4 basic test types. Can anyone remember those 4? We learned 4 basic test types. Can anyone remember those 4? Starting from unit testing. Can you tell me the other 3? Unit testing. Unit testing means individual components will be tested. Individual parts or components will be tested. Then next one is
Integration testing.
yes, integrated testing. After testing individual components, you integrate, you merge, or you combine the units and then test it. That is called integration testing. Okay, even after combining this, you can test it as the entire system. That is called system testing. And after that, you have to give it to the user and test for the acceptance. These are the 3. So units combined as integration testing, entire system is tested, and then the acceptance is tested. And after that, you have the deployment, handing over the system to the intended users. The required users, you are handing over the system. Okay. Again, I'm asking, so how we can hand over? So there are few methods to hand over. Can you remember those few methods? How to hand over? There are few methods to hand over the system. What are they? Yes. What are the methods of handing over in the system? So one thing is you can directly implement. So it seems that you cannot remember. Anyway, next week is examination, right? You have MIEEE as well. And after the MIEEE, immediately after the next week, you have the exam. So you have to prepare. Right. Okay, let me tell the steps. After you finding out, after developing the system, you can directly put the new system into the working status. That is called direct implementation. Here you can see the steps. Direct implementation. Stop using the old system and start using the new system. Stop using the old system, start using the new system immediately. That is faster, but there will be more reluctant from the users. Users may not like this because so people will not like changes. So if a change happens suddenly, they will reject. That initial rejection will be there, but anyway, this will be faster and riskier too. Why it is risky? So what's the reason why it is risky? Yes, any reason to make this risky? Navodi, what do you think? You are new to the class, no? Right? Okay. So anyone can tell why it is risky? So now you have developed the system. Now you have, right? So requirement gathered, planned, development done. Then you have tested, pace by pace tested. This is actually last week lesson. I'm just giving the summary. Tested by unit by unit, kala test karna, integrated and tested. So that means you combine the unit one by one, kali ekatu karla. Then phone ekak nan, you can test this using you can test the screen, you can test the battery. Screen, battery, casing, combined test. Entire phone is tested. Mulu phone ekama test karla balana. ඊට පස්සේ phone එක දීලා බලනවා ඔයා මේකට කැමතිද කියලා. So that is accepted testing. Deployment කියන්නේ පරණ phone එක අයින් කරලා එකපාර අලුත් phone එක දෙනවා. ඒකට නම් ඔයාලා කැමතියි. Even users don't like, you will like a new phone. But systems වලට එහෙම නෙවෙයි. Systems වලට මිනිස්සු එකපාර කැමති නැහැ. System change වලට මිනිස්සු කැමතිත් නැහැ. System change කරන්න එන මිනිස්සු change කරන්නෙත් නැහැ ඒකින්ද. Right? So that is the thing. Anyway, direct deployment. Direct deployment by නම් parallel deployment කියලා එකක් තියෙනවා. ඒ පරණ system එක පාවිච්චි කරන ගමන්ම in parallel with that you are using the new system. In parallel with the old system you are using the new system. So there are advantages because the risk will be reduced. Then make a risky නේ. එක පාරටම අලුත් එක දාන එක risky. මොකද අලුත් එකේ වැරදුනොත් පරණ ඒවත් නැහැ අලුත් එකක් නැහැ. ඒක තමයි risk එක. මේකෙදි අවුලක් නැහැ. මොකද පරණ එක තාම තියෙනවා. අලුත් එක වැඩ කරේ නැත්නම් පරණ එකට යන්න හරි පුළුවන්. That risk is reduced, but more work. Employees ලා උදේට පරණ අලුත් system එකේ හවසට පරණ system එක. නැත්නම් හවසට අලුත් system එකේ හවසට පරණ එකේ හෝ හවසට අලුත් එකේ උදේට පරණ එකේ. ඔය විදියට දෙකේම වැඩ කරන්න. That is a overhead for them. This also they don't like because of the overhead. කලින් එකට ලෑස්ති නැහැ changes නිසා. දෙවෙනි එකටත් කැමති නැති වෙන්න පුළුවන් overheads නිසා. Okay, so actually today we have very few in the class. I think they are celebrating the new year. No? Anyway, next week you have the examination. Be prepared for that. I don't mind. So celebrating new year is okay. That's totally okay. But if you miss the classes, you will miss a lot. So around like 7 or 8 are not there in the class. I don't know why. Okay, then the pilot. The parallel development. Pilot development means you take a sample. 100 දෙනෙක් ඉන්නවා පන්ති. 100ටම දෙන්නේ නැහැ system එක. You give it to 5 people and test whether they like that. If that 5 feedback from that 5 people are okay, then giving that to the other one, other 95. So that is the pilot development. Pilot deployment. මුලින්ම දෙනවා 5 දෙනෙකුට 5 දෙනෙකුට දීලා බලනවා කැමතිද ඔයාලා. So they really like the new system. So give it to the 95, that will be okay. So giving this to 5 people, they don't like that much. They're inefficient, they don't like to work. They reject the system. So better to keep the all systems seems. Acceptance is failed. So likewise, you decide by giving this to a sample, and then maybe you can do some improvement and then give it. කැමති නැහැ දුන්න එකට ඒ pass දෙනා එහෙනම් improve කරලා දෙනවා. Then they like. And then the improved version can be hand over to the others. It's similar to that. And then the pace development. So remember that pace deployment, sorry, not development. Pace deployment means first phase is handover, similar to highway project. You know the circular highway from maybe Kaduwela to Kottawa, or Kottawa to Kaduwela, the first phase. The second phase may be Kaduwela to Kadawatha, that is the second phase. Then Kadawatha to Kelavarapitia, the third phase. Likewise, phase by phase, deployment is done. So that is also a safer way. You give one part first, the second part next, the third part next. Likewise, you give part by part. Will be more safer. But it will take some time, right? It will take some more time. Okay, finally, after all these things, you know, any system will break. Any system will have a problem. Right? Any system will have a problem. Any system will break. And maybe in the future, what you have to do, you have to maintain the system. You have to properly put the guidelines, and you have to maintain the system. Right? So that is what the review and maintenance. Any system need to be maintained. Right? Okay. So is there any problem, any issues? Right? Is there any issue, any problem, any doubt in this area? Because this is your class. I always tell that this is your class. You have to clarify the issues. So don't wait till others are in the question. If you have problem, if you have questions, you have to ask. Then I can answer. Up to now, is there any issue? Anything unclear? තේරුම් නැති මොනවා හරි තියෙනවා. තියෙනවා නම් අහන්න. අනිත් අය ඕන එකක් හිතාගත්තා. ඒක කමක් නැහැ. ඔයාට තේරුම් නැත්නම් ඔයා අහන්න. Because then I can help you. Okay. මොකුත්ම issue එකක් නැද්ද? එහෙනම් මං අහන්නද ප්‍රශ්න ටික? If you don't have issue, shall I ask questions? You don't like that also? No? Right, okay. Okay, I assume that you will not have questions. If you have questions, still you can send me a WhatsApp, right? Still you can send me a WhatsApp and ask, right? Okay. So let's move. Okay. So then today what we are going to learn is system development lifecycle models. Please write down the heading in your book. System development lifecycle models. System development. So heading is system development life cycle models. Okay, so under that, please write. We have already learned phases of SDLC. These phases can be implemented. These phases can be implemented in different mechanisms, and those are called SDLC models. Those are called SDLC models. For an example, if these phases are implemented one after the another in a sequential order, then it is called waterfall model. Then it is called waterfall model. Then write the first subheading, waterfall model. Okay, right up to this waterfall model, and please let me know once you are done, right? So hopefully you understood the concept behind this, and that is waterfall model. Waterfall model is basically, so if these steps are executed one after the another, the SDLC steps are executed one after the another, then we call waterfall model. It's like a waterfall is falling down step by step by step by step, pace by pace by pace by pace. But the thing is, so in a waterfall, it is really difficult to climb up. The practical waterfall, it's really difficult to climb up. So that issue is there in the waterfall model. When you, for an example, think that you have analyzed the system, now you came to designing part. After designing, you started coding. Now a person come and tell you, hey, I need to do a small change in the designing. So, but if you're in a waterfall model, you have to tell that, sorry, no, because we have already finished that chapter. Because why? What will happen? The designers that you have hired, they have already done their duty and left. Now, if a person can come and ask you to do the designing, now you don't have staff even. You don't have resources. Because that phase is over. You can't go and reverse. So that is the nature of waterfall model. For an example, if you need to do reanalysis of a requirement, now customer come and tell you, dear Mr. So-and-so, so it's very good, your system is really nice, but we need to do small change in the requirement. We have small change in the requirement as some of our staff has changed, the position changed, now we need this. But you have to tell, so sorry, so-and-so, what has happened? So now we have finished, we are in the waterfall model, we have finished our analysis phase way back, and now we have even finished the designing phase. Now we are in the development phase, so we can't go back and change. But that is not pleasant, no? That is not nice. But that is the nature of waterfall model, right? Okay, let's write down the description. This model is usable when requirements are pre-identified, clear, and stable. It cannot or difficult to go back and change something related to the previous phase if you are using this model. For an example, if a requirement is discovered even after finishing the design phase, it is almost impossible to go back, reanalyze, redesign, reanalyze, and redesign the system. If the system is simple and easy to define the requirements, this will be one of the best models to apply. Okay, please write down this note. That is about the waterfall model. If requirements are clear, stable, not changing, simple, so no need to redefine. So if it is not ambiguous, then the best model is this model, waterfall model. Okay, let me know once you finish writing, right? Right. Now you know when to apply the waterfall model, and the second model which is listed in your syllabus, so there are more models, is iterative incremental model, the second model. So see, the first model is waterfall model, consists of several stages in linear development to develop system using the waterfall model, following other consideration. Identification requirement of is must, that you have to do first. Complete one stage before going to the next stage. So we discuss about that as well. The result should be deployed to the system. Results of the deployed system is found at the final stage. So that is what I couldn't discuss. That means you can see the final system. System එක හදලා ඉවරුණාම තේර පේන්නේ අන්තිම phase එකේදී. Until then you will not see the visible output because you are in different phases, and finally you release the system, then only users will know the system. That is one disadvantage of this, right? So that I couldn't mention, but that is disadvantage of this. It's there in your book, so I'm not going to do that. The next is iterative incremental model. Iterative incremental model, the second one. So please write down the subheading: iterative incremental model. This can be used when the system can be delivered in a series of steps, and when requirements are not well known or changing. So this can be used when system can be delivered in series of steps, and when the requirements are not known and or changing. So then you can use this model. In each phase, small components of the system is delivered to the user. Within bracket, you can write, in waterfall model, the system is delivered as the last step. Okay, due to early delivery, there will be early acceptance of the system by the users and more user involvement will be there. So these are the points. There will be more user involvement as well as early acceptance of the system. It is possible to add minor changes and even major changes in the middle or in the next iteration, So this is what incremental development model is. It is possible to add changes. It is possible to deliver pace by pace, part by part. One increment, first increment, second increment, third increment. It's like first iteration, the second iteration, the third iteration, the fourth iteration. Likewise, that can be delivered. So you know how COVID-19 injection is given? The first iteration is given to this age people. The second iteration, next set of ages. The next iteration, this promise, this area. Or how schools are opening now. First iteration, grade 12 was, 13 was given the chance. The second iteration, all levels were given the chance. The third iteration, higher grades was given the chance. The fourth iteration, then only all the grades will be started, but that is also part by part. Likewise, there will be different iterations. That is what iterative development model is. So actually, this description is over by now because in your book, they have mentioned about 2 modules and then they have started summarizing the node. But here they have mentioned the prototyping model and spiral model, which has not discussed in this syllabus. But anyway, so as the last part of this chapter, let me discuss that as well and finish the lesson. So today I'll be able to finish little earlier than the usual time. Not sure, right? Not sure. Don't expect that. Because anyway, we have to discuss the prototype model, spiral model, and then the Q&A session, question and answers, because we have finished 2 major chapters. That is the first chapter and the second chapter. And most of the examination questions are coming from these chapters. That is next week, same time. Right, okay. So next, write down the prototyping model. So before doing that, I just want to show what prototyping is. Prototyping. So prototyping is interesting thing because, so you know, this Apple phones, they are developing, they are releasing a prototype. Maybe iPhone, let's say iPhone 13 still not released, but there's a prototype. Prototype means expectation. So this will be iPhone 13, a rumor, kind of. It's not rumor actually. So they are developing the prototype. They are developing a prototype and telling, so this will be the version and this will be added. These features will be there. Likewise, then they will get the user comment. After getting the user comments, so they can develop the actual one. So they want to review whether users like this or not. That's why they are releasing a prototype. Prototype means not an actual version, it's a model. So build-ins also, you have seen the flats or like flats, Colombo, let's say. You have, so like, so this is someone that you can, so not, okay, something like this. model or prototype. So basically they will release a prototype. So here also the luxury apartments, this one also, they have released a prototype. Now actually this was completed, but initially they have released a prototype. This will be the this will be the version that's going to come. That is called prototype or model. So let's say prototype building. Prototype building means so a model of the building will be released first. So this is a prototype building, and this is also a prototype building. You are doing this for exhibitions in your schools, right, to show that something. This is also a prototype build, not actually how it will look like. That is called a prototype. So it can be 3D model, or it can be a physical model like this, a rigiform or cardboard model. So something like that, a prototype. So then you can get an idea from the user. Okay, one thing, if you disconnect, please reconnect to the same link, right? Disconnect way then. Link reconnect. Okay, going back to the lesson. Prototype is actually developed basically for getting user acceptance at the early stages and get the user comments, because then you know what user need. User owner they done, client owner they kalin dannawa nan, we can easily develop that. So that is the idea of prototyping, and this is